Make sure I didn't make the same mistake as last time. I think we're good. Cool. That's Rustbook stuff. IK. I guess I can show the IK at the beginning of the stream. I don't know who's gonna show up early. But the IK stuff is all working, which is sick. Very excited about that. Hello, people who are watching this later. Let's see, where's my... I'm not going to start with IK today. I'm going to go do Skein stuff, I think. I want to do a Skein release. Oh, that's not the desktop I was looking for. GitHub, Rust, Adventure, Skein. This is not the thing that I'm looking for, I think. Yep, that's arrays. Skein Blender 5 is the thing that I was looking for. I should commit that other thing though. Pull, just make sure that I haven't merged anything recently. Code dot. So we have two things going on in, oh, that's a bunch of the stuff that I was working on at one point. This weeb and bevy. That's funny. Not what I meant, but funny. That's not supposed to be there. Cool. Let me dump that over here instead. There's a change log for Skein stuff. So I updated it to work with Blender 5. So for anybody that I guess is watching and doesn't know, I should probably explain what that is in the first place. If I can find a Chrome window, which regular stream watchers will know, I never have a Chrome window open when I need one. So this is Skein. Skein is an integration for Blender and Bevy. It allows you to put components onto objects in Blender and then instantiates that data in Bevy, which is very cool and very useful. It's not terribly it's not trying to turn Blender into a full IDE or whatever. It is literally just like inserting components on things in Blender is very useful. That is a very minimal subset of things that Skein can do theoretically, but it is very useful, and thus Skein exists. So we need to do a docs update because we've merged some docs stuff. We need to do a release of the crate and of the Blender add-on. I have change logs for both of those. So we're looking for, let's see, changes to the add-on, Blender 5 compatibility. Blender 5 is in release candidate right now. I think they're running one of those Wikipedia style fundraising campaigns. But Blender 5 is in release candidate. It was in, I don't know, beta when I did this actual implementation. So yeah, stuff exists. People are going to start using it. We should get the release of Skein out that supports it. Some extra smaller stuff. There's some data that Skein sets in a GLTF, and we don't set that field anymore if the array is empty, which is cool because that means that if you don't use any other GLTF extras or anything, then those components won't get inserted. Less stuff to do. Things are cool. Custom configuration for a BRP host and port. You will be able to, we need to document this. So I should keep a small log of things that we need to update the documentation page with. Custom host port. docs. Basically, the idea here is that I think I have it in my current Blender install. So if you go to the add-on settings, wherever I can get to those, preferences, Skein, there's debug, presets, and now custom host import. So now you can put in a custom host import if you want to send your registry requests to Bevy in a different way. That is also reflected on the crate side, which is cool. And then I updated 2 of the CLI commands in the Blender add-on. So there's a new change component path. So you can use this CLI command with an arbitrary blend file. So here's like a .blend file. So Blender in the background with the blend file that's in this location with a command that is change component path. And then the arguments that actually get passed to that CLI command will run Blender headlessly. And in this case, swap the tunic bush sensor path for a new path, which is API bush sensor. So if you do like refactoring of your Bevy application, you want to change some type path, you can now do that for any use of that in your entire blend file. These CLI commands are fairly experimental. I only suggest using them if you back up your blend file first, but they're very cool. And then dump component data got some updates, which will now jump all of the components that you're using and their data out to a JSON file. So you can see objects, meshes, materials, scenes, cameras, etc. So you know, or you can determine, because JSON is, you know, something that you can easily process. You can determine all of the components that you are using across the entire blend file fairly easily, which is very cool. So these are the new changes for the next release. These are all backwards compatible. We were talking about, smack my mic. We were talking about like Semver and stuff before. This is introducing a new feature. So in this project, I do 0.1. whatever if I'm not breaking anything. Part of the reason that I use the patch version for this is that Blender auto updates for some people, and some people have it installed manually, and any version change is kind of like just communicating to users, if that makes sense. Like Blender doesn't understand the difference between these Semvers. They're just kind of like, hey, there's a new version or whatnot. So people basically just click update no matter what that version is. So if we're just adding new stuff, then we're good to go. So that's the new stuff in the Blender add-on. There's some new stuff in the Rust crate as well. The Rust crate got some more interesting changes, I think. Some changes to how we configure or enable BRP on WASM, which I guess we need to document this too. Right. I changed all of the, so Skein uses something inside of Bevy called BRP, or Bevy Remote Protocol. Bevy Remote Protocol is basically an HTTP server. You can get all the registry information from that HTTP server, turn that into things you can actually work with inside of Blender. And when working with that inside of Bevy, we can add those like custom endpoints that Skein needs to the BRP server kind of after BRP has been instantiated. So if somebody wants to set up their own BRP, or another plugin is adding their own endpoints and stuff, we want to play nice with that. So I made some changes to make that a little bit nicer, which means that users can now set up BRP however they want on their own if they want to override kind of like what Skein does. We get some new debug logs for things like where the BRP server is running, which is cool. And I guess that's it. But this is like these config changes and stuff mean that I'm going to do a 0.4 release for the crate and a 0.1 I think 13 is the version for the extension. Let's get rid of these dev versions. Commit version bumps. We're going to git tag. I think this is going to be 0.4.0. And then we'll git tag Blender 0.1.13. We'll git push with tags. And we'll do the release for cargo publish, which should just work. This will run our build and all our tests and stuff. These publishes don't really depend on each other at all. There's no like requirement to have one version or another. I kind of designed these things intentionally like that. There is like, if you upgrade the Blender add-on, the only thing that you need to ensure is the correct version is the BRP endpoint for the registry schema, which we do some discovery of inside of the Blender add-on. So generally speaking, if you keep the Blender add-on up to date all the time, everything just works. So it shouldn't matter which version of the Rust crate you're using. The Blender add-on should work with it. Now you might miss some features if we add new features and stuff, but such is the way that it works. So just we'll build our Blender extension. That will drop a zip file with all of this extension code somewhere, which I always forget, in the root right here. So I'll just reveal that in Finder for a moment. And then we probably also need, I have a separate repo that I have always open to the Skein docs. So maybe we pull that up. We're going to write some docs in a second here. So I don't know why everything keeps switching over to my other monitor. So I'm going to pull because I know there's some changes. I'm going to open this. This is a little bit interesting in terms of architecture. So we're going to cargo make serve, which will do some build stuff. The big change is going to be that once we publish this, well, a couple of things really. Where's our Chrome window? Chrome window. Hey, Anders, how's it going? Just doing some Skein release stuff. Just pushed a couple of things. Just published 0.4. The 0.4 will let you actually contain some changes to how WASM is configured. So that's why 0.4 instead of 0.3 whatever. And then also lets you set up BRP by yourself if you want to, which is cool. So I think we probably want 2 releases. Maybe we want 1 release. I think they're the same release anyway. Where are my tags? Tags here. We pushed tags already. I feel like the way releases work are kind of awkward. Because like I want to select both tags, right? Like I want this to be like 0.4 and Blender whatever, because I have effectively 2 packages in here. But it is what it is. Any breaking changes should not be any breaking changes. The Rust crate I bumped to 0.4 because I added some configuration changes. So it shouldn't have much of an effect on anyone, but theoretically it could if you were using certain configurations. But there's no breaking changes between the Rust crate and the Blender add-on or anything like that. So everything should just work. You should be able to just upgrade, and things should still work as expected. So Bevy Skein 0.4 and Blender add-on 0.1.13. I don't understand what this is generating. Automatically add the markdown for all merge pull requests from this diff. I mean, that's a cool button, but I already tracked it. One thing I didn't do is update the change log. So let's do that. We have the zip file, which if I can squeeze my fingers on my computer, I want to drop the zip file here for the Blender add-on for anybody that does that kind of install. We're going to need to make a docs change for the URL. The change log here for Blender, this is no longer unreleased. This is now 0.1.13. And this is 0.4. And technically these happen, but who's counting? 0.2.0 to, no, 0.3.0 to 0.4.0. Let's call this, I guess, 0.2 .x. These, I guess those don't really matter. Anybody who's clicking on that is kind of using a very old version anyway. So let's do 0.4.0 to head for the Rust crate, and then 0.3 to 0.4. Those URLs should work. And then we did 0.1.13 here, which I am doing a terrible job of kind of keeping up with. So I'll come back here and maybe fix this. 0.13, and this is 12, and this is 13. All these Git tags are already created, so theoretically they should still exist for the other releases, but I guess I did a bad job. So I'll go back and check those URLs at some point, make sure they all work. Cool. Releases. The way we do like the release is effectively we put it on the doc site because it has a static registry. So really what I'm going to do is take the docs that I just kind of like knocked into each of these releases and dump them in here. This is going to be Blender add-on changes 0.1.13. And then we'll have another one for the Rust crate changes. I guess the thing that people really care about is the add-on changes, so let's stick those on top. I feel like the Rust crate is really not terribly exciting. New changes. Yeah, some changes. Some changes. Nothing breaking, so it should just be fine. Rust crate got a couple new logs. I changed the rust crate to kind of behave better. It hasn't caused an issue for anyone because I think most people don't use other BRP stuff. Or if they do, then Skein kind of like is kind of one of the only crates that adds its own endpoints and thus would be the only one that this matters for. But I want the crate to behave in a little bit of a better way in the ecosystem. So we added the ability to add the custom BRP methods that Skein adds in plugin finish, which also enables you to set up BRP on your own. So now you can set up BRP entirely on your own, add your own endpoints, do whatever you want, and Skein will just like attach to the resource that is created when you do that in plugin finish, which is cool. None of these are breaking changes; they're just kind of like improvements. And then some configuration changes for WASM potentially. Yeah, some new logs that will show you the endpoint that the server is running on, just in case, and tell you if it added. And then the Blender add-on, Blender 5 compatibility is the big flagship. This wasn't like tough to do. It was, I think, there were some changes in the way that custom properties versus ID data is stored. They are now like firmly separated inside of Blender. So that changes whether you can use square brackets or like key in thing or like things like that, which is really awkward, but really only required like me changing like one word or one line to get compatibility, which is sick. Some other things that are, custom configuration for the BRP host port. Some people have been asking for that on Windows. Or actually not on Windows. Somebody is running Linux talking to a Windows machine or something along those lines. And 2 new CLI commands, or rather I've updated the old CLI command that dumps component data to be up to date with everything that we do inside of Skein. And then this command allows you to take an arbitrary blend file, run Blender headlessly, and change a component path from an old path to a new path. So if you're moving stuff around inside of your application, this should make it easier for you to change type paths. Now, my suggestion moving forward, generally speaking, is to use the type path macro for anything that you intend to use externally. So this becomes like API no matter where it is in your code base, but for people who want to move stuff around and keep those paths or whatnot, this is good. So maybe a little bit of a key feature for this release is Blender 5 compatibility for the Blender add-on. Custom BRP configuration is also now supported across Rust Crate and Blender add-on. New CLI commands for Blender add-on. I should capitalize Blender if I'm capitalizing Blender. Yeah, I guess that's really it. And then changes to how BRP feature is handled in Rust Crate, especially with respect to WASM targets. So that's that. This is it. Previous tag, I guess we'll tag 0.1.12. I don't know if that matters or if that's just for the generate release notes thing. And I think people care more about the Blender tags than they do the Rust tags. The Rust tags are like easily introspectable on docs.rs or whatever. So I'm not as worried about that. The Blender tags for the add-on are generally like they don't have another place to be. So we'll publish this. This is now just a markdown doc, and you can download Bevy Skein here. I guess I should have said something along the lines of like, there are no breaking changes, but I forgot. So maybe we come in here and we do that. Can I save this? Update release. There should be no breaking changes for users, but we've set the new Rust crate to 0.4. Count for WASM configuration changes. Cool. So that's that. That is out now. Now, the big thing for us is going to be that people don't really receive it inside of Blender until it's on the website. So let me change logs, push that up to the repo so I don't forget. And then we've got the docs over here. So I took a couple of notes. I think we needed a new docs page for the configurations. Where did I take those notes? That was over here, right? There we go. These two things. Custom host port docs and document the behavior of BRP on WASM native custom. So custom host port docs are probably the most relevant, I guess, or the newest thing. But fundamentally, we do have to do at least one thing here. The application itself doesn't need any changes. Where's my static assets? Releases. So we have Bevy Skein 0.1.12 here. And really what I need is Skein Blender 5, Bevy Skein zip. And this goes into assets releases. That should show up over here now. And then we delete 0.1.12 because that's just how things end up going for Blender for whatever reason. I think I have my generate static index task here. So now this index.json should point to 0.1.13. Minimum Blender version currently is 4.2.0. That's still true. That's kind of just because we like started with the 4 dot whatever branch more than anything else. But the other thing is that 4.2 introduced all of the new extensions stuff inside of Blender. So instead of being like random add-on whatever, there were some configuration changes. So that's really why we are lower bounded at 4.2. We theoretically could go easier, or earlier, but Skein's support is kind of like for the LTS releases, and if the LTS releases phase out and are deprecated, then we stop supporting them. So not really concerned about that. The docs here for installation and stuff need some updates. So let's do The one thing I didn't do in this repo is organize it in terms of the way that it is on the website. It's just a folder of files more than anything else. So if we look at the actual docs page, we've got overview. We've got some maybe updates to overview. Register components using register type. We're going to reverse this. This is no longer necessary. So we're just going to remove that entirely, I think. This is the like register components. Fetch registry information from your Bevy app and store it in Blender. Insert Bevy components. Export to GLTF. Components are instantiated. I think that's still a fine description of what things do. This, I think, already got updated. This is the quick start. This is 0.17 stable using the Bevy CLI or cargo generate. I kind of stopped advertising that there are older versions, but there are older versions. Like you can get to 0.16 if you really want to. Maybe we do that. Maybe we include like the older stuff as well. I think that at this point, if you're on 0.16, you're probably not starting a new project. So I'm not sure how relevant this is, honestly. I think I'm going to leave it out. So this does some stuff. I think that node is still fine. This is getting started. We don't need to register here anymore. Since this is kind of like the getting started, you don't really need this anymore. Like that whole section can just go, which means that this can be one code block. Install type registry. I guess this is like a decent time to put a note. This is component registration is done automatically in most circumstances in Bevy 0.17. If you have generic types or want to register manually for any reason, you can use app register type. And this will just go to latest. So we'll keep this note here, just kind of like a like if you run into something, if you have more advanced use cases, they are supported. Information stored in your blend file, yada yada. Cool, that all looks good. Installation, I think this is not going to change. There's nothing in here that's like super special. This is no longer true though. The installation. This is still true. No, Skein disables BRP on WASM. Targets. It's not like it disables. By default, Skein does not enable BRP on WASM targets. So if you're doing this and you're doing default, don't expect it to run. WASM targets in release mode file. By default, Skein does not enable BRP when compiling to WASM targets. You can see why I like Typist. I have so much text to manage. By default, Skein does not enable BRP when compiling to WASM targets when using a release profile. Skein still operates on GLTF extras. Warning about GLTF asset labels. The other thing that I think we forgot to do that I haven't done yet, or rather, the overview index page, which might be code level, actually, now that I think about it. Not crates. App, source, pages, homepage. This is a Leptos and Bevy ECS data powered site, which is very cool. So realistically, what I should be doing is fetching this information from disk, but that's not what I'm doing. Bevy, Blender, post title, open graph image, description, docs layout, docs header. Did I forget how I built my own site? Bevy, Blender, this is what I'm looking for. This is title, previous, next links, pros, docs header. Hero, view on GitHub. Oh, maybe I do actually do this from disk. Do I? Do I actually do this from disk? I'm so proud of myself. I didn't realize I did that. Hang on. Let me just make sure that this actually does do the thing. What's the problem here? Is this... WASM bindgen. WASM bindgen is always the issue. Always the issue. Specifically because when I use things like... whenever you compile to WASM and you use WASM bindgen and you use something that tries to use the WASM bindgen CLI or something similar to it, or something that calls out to it like cargo leptos, then the version of the library you use for WASM bindgen has to match exactly down to the patch version for the tool that the CLI is calling for you. This is annoying because it means that if you have multiple WASM projects, so multiple Leptos projects or multiple Bevy WASM projects or multiple, doc sites like I have right here, then you need to pin WASM bindgen across all of those projects. And the thing that they didn't really do is provide a good way to install the WASM bindgen CLI locally for a specific project. You can totally do that if you set it up yourself. It's just like mildly annoying to have to do so. So now this is 0.1.13, which correctly formats that URL. But there is one more place we need to update it, and that I believe is in installation. Because this doesn't change because I'm not passing data. Like, this is one of the things that I think the typist would make easier, because when I would compile the typist, I could pass in this data and then template it in here. But in Markdown, you're kind of out of luck. Cool. And then we got down to fetching the registry. Run your app, have the add-on installed, fetch Bevy type registry. What does this do? That all works. Inserting components, objects, meshes, materials, scenes, lights, collections, and bones. Those are all the things we support. Somebody asked for vertex groups. I don't think we can ever do vertex groups. There's no like place to latch on to vertex group data. So I don't know. I'm leaving that issue open just in case something comes up, but I don't really think that we'll be able to do that long term. There's a couple of pieces of documentation here that are like, hey, materials are here, lights are here, scenes are here, bones are here. Because not everybody is familiar with the interface. But I think everything else here is fine. Defaults and presets hasn't changed. If you want this to happen, you still have to derive it. You can insert presets, etc. None of the rest of this has actually changed. Exporting hasn't changed. Collections hasn't changed. Yada yada. Table. This talks about stuff that I think that I'm the only one that might care about. I guess controlling the type path. This is something that I should just do in all of the examples, I think. That's what I should really do. Like this marker component here, docs getting started. I should, in this spot, take this, put this here, also derive default. Like, instead of doing the minimal thing, do the maximal thing that people would want. So in this case, component reflect default, reflect component and default. Because then people will get the defaults there. I guess for a marker component, it doesn't really matter, but maybe I should do a different component here anyway. Let's do like name string. And then we can just call this my component and it doesn't matter. Then installation. It's all good. Fetching the registry, all good. Inserting components, all good. Defaults and presets, this mentions it. Player should also get the same. I think in general, in the docs, I want to point people to something that will kind of like work for them longer. So I'm going to include this type path everywhere, even though it's not required. Because I think people should do it, because people get frustrated when they change something in their source code and then it moves in Blender. And then they have to, the way it's currently set up, they have to like hit that problem, experience it, find the solution, and then implement the solution, which can be kind of annoying. So in our case, we will point people in the right direction to start with. Exporting basics, components, sub-assets. None of the rest of this has components, I don't think. Component definitions, anyway. Migration tools needs an update. These have new outputs. Dump component data and the other one. The other one. Okay, so where's Chrome? Rust Adventure Skein. This is the release. I dumped this. Let's grab this and put it into migration tools. This is no longer the, well, it's going to be the same thing. But let's just get the new output here. I think this, actually, we run this on a specific file in the repo, so maybe we want to do that instead, now that I'm thinking about it. The Skein here to test.json should dump out test.json. And in this case, dump component data. In this case, I didn't have the most recent version. Let's see. We haven't published the site, so I can't install it from the site yet, which is awkward. Let me do a manual, just copy for dev, which should mean that this preferences, this is 0.13-dev currently. I think I need to reboot for this to take effect. Oh, no such file or directory. That would be, you know, that is an issue. Assets, replace material. No such file or directory. Why is there no such file or directory in here? Is that because I went nuts and didn't include the blend file locally? Okay, sweet. That's what I should have done. I don't know why I didn't do that. Let me go to the other GitHub Rust Adventure Skein. This is one that just kind of like has everything, or should, I think. I really thought I did that. I guess I didn't. That's unfortunate. I'll have to recreate that. This is assets. Oh, maybe that's it. I put it in the wrong, okay, I went to the wrong directory. That's what I did. Let's do Blender B. This is going to be for Tunic. So we're going to do, I guess, the one over here, right? ls art. It doesn't really matter. cd Skein. I have so many Skein directories. It's kind of a problem. The real problem here is that what do you mean it doesn't exist? I was just looking at it. Demo, Skein demo is what had it. ls art. backup, tunic. This is art slash tunic.blend dump. And this is open test.json now, which now has stuff. So let's grab that and do to JSON PB copy, which I think is the same output that I actually had. So I just did a bunch of work to rerun this command for no real reason. I guess I want the unrecognized components in there, so the old one is going to be better than the new one. Because this one doesn't have... Yeah, I think I do want the old one, actually. I want this to show up as unrecognized so that people can see it. Well, that was a mistake. The other thing is we did this, and this is got a output in the PR. So we can do not filtering. This is going to be another example. And that's going to be replace an old type path with a new type path. I guess this isn't technically type path. I think this works regardless. So I don't want to say type path here. I want to say replace an old component path. Component path with a new component path. And the name of this CLI command is CLI change component path. Which I could have looked at the docs that I just had there because it says it right here. I don't know why I did that. Cool. And then this will go here like this. So this is substantially like smaller output because it only shows components that were modified. We need to put a warning here though. I always forget. Is this warning? Guess I'll never know. Warning, back up your blend file before using this command. It will mutate data and save the file. I guess theoretically, one thing we could do is make that command in the future save to a new file, but I think that's more confusing for people. Important migration tools are experimental, filtering previous. This is not localhost. That's why it's not refreshing. Always important to actually be on the development site if you expect changes to come up. So warning, back up your blend file before using this command. It will mutate data and save the file. This all looks good to me. So that's pretty much all of the relevant documentation. The contributing and whatever stuff is um, not stuff I really expect anybody to ever read. I wrote it just in case people are interested, but gonna be honest, um, working on Blender stuff is probably not what a bunch of Rust developers want to do, because it's basically writing Python. Let's change this to API reflection. I'm using API for these. This says Blender in a bunch of things, so we need to go change that, I think. Actually, no, we don't. Here is, and I didn't finish that sentence. Blah, blah, blah. Here is an example component. Let's make sure this link works. This is not a link to latest. This is a link to a specific version, which is fine. But we just need to make sure that this is actually what we expect it to be. Okay, I think that's it for the most part. I think I'll do the custom host port docs later, because basically that's just going to be the same stuff over and over. So cargo make, build. Is building in release mode and stuff. So I guess overall it takes me, if there are documentation updates and stuff, it takes me like an hour to do this release. Mostly because I try to keep the docs up to date as we do releases, but not too bad overall. I think if things don't really change, like if there's a patch release, then this isn't really an issue. It can go even faster, but I do the build locally too. I could do the build in CI, but I don't. So this is 0.1.12. This will show 0.1.13 when this is done. We do need to run the actual deploy command, but this is going to have all the build already done. Yeah, I added this note for myself because I did test actually allowing older versions to show up. And it seems like Blender will just repeatedly reinstall old versions if they exist, which is awful. Cool. So now it's 0.1.13. Everything's released for Skein. Blender 0.5, Blender 5 support, things like that. The one thing that I do like to do after doing a release is make sure that I have, which I currently realize that I haven't actually. Let's do temp, gh repo, clone, Rust adventure, Skein. Yeah, no, Skein already exists. Skein. This needs to bump to 0.4. Skein template update. This is GCO template minimal. I'm getting real tired of VS Code constantly popping stuff up every time I open it. Okay, so this is all fine. One of the things that I want to add here is type path API. Make sure that that is fine and works. This is the same thing we do on the website, right? Type path equals API. Do we have default here? We don't have default here. Let's add default. So let's just take this whole chunk right here as if we're doing the quick start and put that in here. Because a bunch of people will just do this and then like copy this over and over. And then cargo toml, this is going to be 0.4, 0.17. I think everything else is fine. Commit m0.4 update push. And then we have the option to actually follow the quick start. The downside of using the Bevy stuff, let's see. 2. 3. Can you tell that I do this a bunch? My newest project, 4, is the one that we need to run. So if this fails, I've done something wrong and need to fix it. And if it succeeds, then everything's good. Skein is out with the new versions, which is super exciting. I guess in the meantime, for anybody that wasn't here at the beginning, the multi-end effector fabric stuff is working, which is cool. What else? What else? What else? I think that's really it. I want to do some Rust language stuff, but I've got a lot of pedagogical stuff to write today, I think. So I don't know how long stream will be. I think Skein might be the vibe. Yada yada. Cool. Massive Cloudflare outage today, so thankfully that didn't mess with our publishes. A bunch of other stuff that I want to do here. Light map baking, multi-select component insertion, Interesting thing about Blender 5 is that it changes the way these menus work. These menus will just like live forever, which is kind of interesting until you like click out of them. Which theoretically means that this menu that pops up once you've selected a bunch of components could actually end up um, like being used to insert multiple, but I'm not sure about that workflow yet. Light map baking is working. We need to make some decisions here. All the actual baking is working, and we need to decide how those things are going to get put into a GLTF file or exported standalone, and if we need to construct new materials to hold those images. Hey, Maui, how's it going? Just doing some Skein stuff, or actually finishing up some Skein stuff. Character doesn't implement debug. Oh, I removed the debug implementation from the template. Of course I did. Okay. That works, other than the fact that the GLTF asset needs a change. Because now this is just going to be API character. So 2 changes. One to the demo.gltf file. We no longer need to use the crate name here because we've put type path in. And this, I want to change the ordering of to match. But also we need debug here. Cool. So that works now. Which is exciting. New Skein release. I guess I'll post about that later in Discord and stuff. But it is out and available. If you have Blender, you can update Blender now. Not update Blender, but you know what I mean. I mean, you can update Blender if you want to. Let's go check Blender 5, I guess. Theoretically, I guess I don't want to do that right now. Let's do edit, preferences. This is going to pop up on my other monitor, of course. I don't know what the deal with, because that's exit full screen now. I don't know why these 3 dots on Mac OS now don't show up half the time. So here's Bevy Skein, which is 0.1.12. This is like the development version that I was working on. We can disable that for the moment and enable the other one, which is 0.1.9 right now. So what I'm going to do is pull up Blender 5. Go to preferences. This should be 0.1.9, get extensions. We will click update. And I guess I should update my other plugins while I'm here. And because I have no idea what they did, I'll restart. But this is 0.1.13. So Blender 5. I guess I have the beta. I should download the RC, right? We'll do the beta for now. I'm not going to download it. So if I go back to GitHub, Rust Adventures, Skein, demo, right? And I cargo run this, it should just be ready to go. Perfect. Perfect. This is currently set up to show off some of the standard material layering stuff, but we're not really interested in that at the moment. What we're interested in is hitting this button, which works, and looking for, oh, I don't know, calling this a bush and inserting it, and that works. So we're good. Hype. That might be it for today. That might be a short stream. I have a lot to write today, I think. I've got to catch up on This Week in Bevy. I'm a little behind on This Week in Bevy at the moment. The IK stuff we've been building is working completely. This is a new implementation. I guess I'll cover this before I stop. This is a new implementation. Let's open the code, I guess. It should already be open somewhere. Yeah, it's open over here. So we've got in the Bevy examples repo now about 3 inverse kinematics directories. The first one is in 2D. That is just a straight 2D implementation. It's the one we did a couple weeks ago. It was only like a week ago. The next one is 3D, so it takes the 2D and replaces vec3s and quaternions with the F32 angles. And then this is the multiple end effectors version, which is the thing we needed to do before we did the bone constraints. So the multi-end effectors version is interesting as a departure from the other versions, specifically because this IK root is no longer needed, actually. Specifically because it becomes tougher to... Let me get rid of that log, too. One of the cool things about the way it's currently implemented is if I take this output that I'm logging here and I take it to GraphViz here and I dump it in, this is our bone chain and all of the distances. So this is entity 18, 20, 22, etc. With the bone distances between them and the directional arrow for which way they're going, which is very cool. So that is just getting dumped out by the program now. This doesn't need to be dumped out all the time. So maybe we just get rid of that for a second. And of course, the thing that I just removed that we're not using, I'm importing for some reason. This IK root component is no longer necessary at all. So you can see everything working. In this demo, we've got basically a chain of bones or a chain of joints. Bones are kind of like the space between the joints. We've got sphere meshes on all of the joints. And as the first children of those joints, we have meshes that are supposed to be tracking the bones. The one place where I'm not sure what the answer is at the split. So we've got effectively one transform hierarchy that starts at the root, at the base here, goes up, forks into a Y, and then the 2 end effectors at the end of the Y try to track these larger sphere targets. And they're individually tracking different targets, which is cool, and keeping their distance and everything. So everything's working here for the IK chain stuff. We're about ready to move into like GLTF and 3D stuff on one of the streams. We'll see though. So there's some interesting next steps, but I'll get to those later, I guess. So the way that this currently works from a user perspective is you set up all of your bones. Maybe you do this in GLTF and Blender. whatever. You set up your bones, and you get these inverse kinematic end effectors. They specify a number of bones that they're going to affect, a tolerance for the target that they want to reach, and the target is also specified here. And if we look at the update target here, this is just a random function, random system, user side. This looks for marker components for those two spheres, and it looks for the two end effectors. And then literally all it's doing is moving the spheres and setting the target for the end effectors to the position of that sphere. So this is nice because it allows you to kind of target the end effector to anything. It doesn't need to be an entity with a position. It can just be anywhere. And then we get into the actual implementation. So the implementation, you can see the inverse kinematic end effector component here. And then we've got still just the same one, like process inverse kinematic system. This does a query for all of the end effectors. It does some gizmo setup. We've got a parents query here. Query for all the transforms with mutable access. Query for all the global transforms. We use the local mutable transforms to set the position at the end. We keep track of the end effectors we've processed, and we have one giant graph for all of the end effectors, or all of the IK chains. So this is all code for if there is a new end effector, insert that end effector's nodes into the graph. This is pec graph now, so all we have to do is take that graph local for the system, insert the entity as a node, insert any parent entity as a node if we have one, and then draw the edge. And the edges of this graph are the distance between the bones that we find when we discover it originally, which theoretically could be set by a user, but for now they're just, the distance between the nodes. If we've got any new roots from that end effector situation, we set those new roots. And pec graph is allowing us to do a bunch of interesting querying here. So we have inserted all the graphs, we've set up all the edges. In this case, we check for any incoming edges to the node and count how many there are. If there's 0, then it's a root. Insert that root. Positions here is the equivalent of a current position in our previous implementations. It is a hash map from entity to global position. So in this case, vec3. We set up all of the positions here by grabbing them from the global transforms. And then we iterate over all of the roots. In this case, we have one root. So we're only iterating over the one graph, so to speak. We get our original root position. We get all the end effectors. We do this via graph queries effectively. We could cache some of this data probably, but right now I'm just calculating it. We have a function for determining. One of the big differences between a single chain and multiple chains is that for a single chain, it's very obvious whether one target is on one position. But for multiple end effectors, you have to check if all of them are in their relative tolerances. So we have to iterate over all of the end effectors for a given root. Grab the end effector and then check to see if that end effector's distance to the target is less than the tolerance it wants to be. Hi, something looks weird. That doesn't help me, Xavier. Hey, Saurav, how's it going? At some point, the left target is out of reach? I don't think so. Left target is always in. Unless you're viewing a mirrored version of the thing. I don't see, yeah, the right target, okay. Right target does leave. The right target does leave the reachable area. Right. That's why we end up getting the straight towards the target kind of orientation. It didn't leave the area when we had two splits, right? If we had two different routes in different positions, that would be reachable. But in the current implementation, that goes just out of reach, and that is intentional. So we check for all of the end effectors to see if they're matching with their tolerances. We do our classic, like, less than 10 iterations. This seems to resolve extremely quickly. Yeah, it's out of reach because of the root, not the other target. Yeah. I don't have a test set up for if the two targets go too far away. But what I think should happen is it should just split the difference if they both miss. One of the things that I'm not doing right now is checking to see if it's reachable and then bailing out if it's not reachable. There's a couple of, I think I have the paper open over here. Fabric, extending fabric. So extending fabric talks a little bit about closed loops, which we haven't gotten to yet. Leaf joints, forward and backward reaching inverse kinematics implementation on special cases. So special cases, the very first special case, I think, is just looking at the headings here. So multiple end effectors is what we've done. That's in the first paper and mentioned in the second here. Reachable or non-reachable targets with multiple end effectors becomes a little bit more complicated, because it's kind of like, okay, there's a number of things you can check. You can always add more rules to check more stuff, etc. Regarding one of your comments you said after the stream for a C format or a Clang format, you saw. Regarding one of your comments we saw after, for a C formatter, Clang format. Yeah. I think I missed that. That must have been, I don't know, one of the other streams. So reachable or non-reachable targets is kind of just an optimization at the moment. And depending on how you optimize it, you get different results. So currently, I'm just letting the algorithm run, and letting it run 10 iterations and time out is basically good enough. And it's not that much extra work. So we could save some compute time. We could optimize that. We could bail out early. We are not currently doing that. There's also a couple of other versions of this that are interesting. But we'll get to that. So we have our iteration limit at 10. Because I haven't really tested different values. 10 is just like, 10's been enough. 2 also seems like enough, which is kind of fun. I don't know. Is this like it is iterative and it does like resolve over time. But like it basically resolves at some point in one iteration and doesn't need much more. So that's kind of really cool, right? We probably could slow this down if I do 10, 100,000. If we let it do 1 million, I think when it reaches that out of area, it will, yeah, there we go. So if we let it do 1 million iterations over this graph, when it doesn't reach, it then slows down the entire application. Now this is doing 1 million iterations, just to be clear, of the full graph, forward and backward, etc. And still, as long as it's within reach, it's fine. But this is the bailout condition. Classic Jacobian and Gauss-Seidel constraint solver. Is it converging? What special cases is not converging? What solution is it converging to? Nobody knows. So the only time that we hit this max iterations right now, I think there are two times we would hit it from previous experience. One of them is if it can't reach to that distance. And one of them is if it can't reach inside itself. I think I'm going to sneeze. So it's really interesting to see like the kind of impact here, where in the cases which we do hit the iteration limit, we can make it do an arbitrary amount of work because we're not bailing out. But this doesn't need this many either. So like, it's also interesting that it does finish. Like, it's interesting that with 1 million iterations, we still see a frame rate. But we can bail out much easier, or much sooner, for less than 3 iterations. And that's effectively the same thing as we would be doing anyway for bailouts, minus the additional computation cost of like figuring out if it's bailable or not. So I think doing 3 iterations on an arbitrary number of IK chains, if we can do 100,000 of them or whatever we can do, then that is quite a few. The use cases that I have for the IK stuff currently is like Tunic level. Tunic has like, I'm going to say like 10 spiders max on screen at a given time. So we're talking about like 30 iterations total. So unless this causes a problem, right? Which theoretically we would want more, but unless this was actively causing a problem, this is well beyond performant enough. But again, I haven't done any benchmarking on this either. That's a good suggestion. The reason you were asked is because you're in a team not using a single editor or tool, which is causing formatting issues. In general, you do use lazy vim. Yeah. So we have a graph, right? We have this graph of all of the nodes and all of the edges. And we do 2 iterations. We basically have our forward pass, our backward pass, our diff update, which is this value here. And then we have to do all the transform propagation. The transform propagation hasn't really changed, but how we iterate has changed. So we end up going over the graph in depth first, post order, which basically gives us all of the edges, all of the like child edge nodes. So if we were looking at the Chrome window that is never local, depth first post order will go depth first down to 34, then give us 32, then 30. Then it won't give us 24 yet, but it'll go down to 29, 27, 25, and then it'll give us 24. This is really important because in the 2D and 3D demos that we did before this, we were doing like the chain itself. We were operating on a chain like set of nodes. And by putting this into a graph, and by doing a depth first post order operation here, we can ensure that everything beyond a subbase is processed before the subbase is, which means that we don't have to worry about doing this in any particular order, right? We already have our ordering. And the only ordering we really care about is that everything before you or before a current node has been processed. So instead of doing like full chain processing, we're doing like node to node processing, which means that, like I said, we can do kind of like any arbitrary node to any arbitrary other node as long as we've processed everything before it, which was a key insight for the graph approach. We're using pec graph, so that's where our graph implementation is coming from. We could do a custom graph implementation and whatnot, but I just didn't. It's not really that worth it unless we're doing benchmarking and doing improvements. So depth first post order in a directed graph, neighbors is children. So we check the number of children for any given node. If there are no children, that means we are at like that very end node. In our case, that is always an end effector. But as we'll cover in a second, there are cases where end effectors can be in the middle of things. So we aren't handling that here yet. If it has multiple children, then we need to get the centroid because we're at a sub base effectively, right? So if we are at, I need to move this Chrome window. If we're at node 24, then we have two children, 30 and 25. And we need to do the calculations for 25 to 24, which will want to put 24 in some position. And then the calculation from 30 to 24, which also wants to put 24 in a different position, or usually a different position. So to fix that, what we end up doing is taking the average of all the children's positions effectively to compute the centroid point. So the position that we do for any node really, including ones with single children, is we grab the total number of points, our vector, accumulated vector, the number of children there are that we're going to deal with, and then we average it. That gives us a centroid, which is sick. So with that, we've done the forward pass. So forward pass is legitimately now just this one depth first. And our end effector case is here. All of our other cases are here, which is kind of nice. It's like very compact. It's compact in kind of the same way our other forward pass was. It's just written a little differently. If we look at the other forward pass, we broke it out into a function, and we had like one condition for the initial, and then everything else went through this other condition. Here, it's a little bit noisier because we're dealing with more things where we're like grabbing the entity from somewhere else. We're basically grabbing it from a hash map, which theoretically can always fail. So we have a little bit more error handling, but otherwise it's grab the end effector target, put it in the position. This is like a two-line thing, right? And then here, because we have a more complicated case, because we need that centroid, we process all of them in a loop, and then we set it. So that's forward pass. Backward pass, effectively the same as the other code we had previously. So in the case where there is no incoming edge, which means we are at the root of a graph, then we just set the position to the target specifically. So we set the root for our backward pass, and then for everything else, we do the calculation for the angle, and we put things in the right positions based on vectors. It's really nice to be able to like grab two nodes, ask the graph what the edge weight is, and then just get it. So we do all the calculation for bone lengths like way ahead of time. And then we just like, I have two nodes. What's the edge between them? And that has the edge weight. I think this is where we will put constraint logic as well. So at some point here, we're going to do restrictions on how much joints can bend and things like that. And maybe we'll do prismatic joints or something at some point. I'm probably going to kick prismatic joints off for later. But we can also put more data here. So we don't just need to put bone length here. We can also put like what kind of joint this is, right? Because if there's a bone from one to another, and one of them has a, like the node can be a particular kind of joint, then if you have something coming from that node or going into that node, we can do the calculations that we need to. And then finally, we do the same thing we did originally. This is the diff calculation that we've talked about a bunch at this point. End effectors for root, iterate over them, check to see if the end effector is within the tolerance of the target. This is some gizmo stuff. Again, we can just grab all the edges from the graph and draw an arrow, which is just like, this is really nice. Just putting things in the right data structure, really nice. Now we do have some more error handling than we would have otherwise, because we don't have the positions in the graph. We have the positions stored elsewhere. I don't know if putting the positions in the graph would help us at all. We could potentially do it, but if we get all the edges, we get the positions, things are great. And then we have to do our global transforms. So we're building up a temporary cache of these global transforms so that as we do depth first search over the graph, we basically are doing everything that we were doing before. So like for the first node, it just needs to set the rotation based on its parent, or rather not the parent, but the root node that doesn't move needs to set its rotation based on where the next node is. Now there's an interesting case here where I just had to make an arbitrary decision, and that is the sub base. Where does 24 rotate to? Entity 24 has two positions it could look at. We could do the centroid of the two positions, but then theoretically, like, what do you do if there's like 5 of them or something like that? I don't know that even setting a rotation in that context is useful. Maybe it is. Because like theoretically, if we let this rotate unbounded, that is kind of like a spoke, you know, which is interesting. But if you have a spoke, then I don't know. Maybe that rotation is useful. Maybe it's not. I don't have an idea right now. Currently, we just do the easy thing, and we set its rotation to the parent. And that's it. Otherwise, our code is the same. And I broke out a little function here for calculating the transform and the rotation. So I think that vec3z right now is an arbitrary choice for us, but this is basically forward. Like whatever we consider forward for this interaction, vec3z is forward currently. So next IK stream, we will probably do GLTF stuff or something like that. I'm relatively happy with this. It's like, 400 lines of code with comments to do the inverse kinematic stuff. There are a couple of things to consider moving forward. The 412, here's the example you were talking about earlier where the targets are too spread apart for the maximum opening of the two joints to fit into those targets. We aren't doing that check. We don't really need to. We can just bail out and it works fine. So if the iterations are low, bailing out doesn't matter. If the iterations are very high, then we can save a lot of computation by bailing out. But we haven't needed more than like 2 iterations to get to the right position, which is really interesting. Maybe there are situations in which that is more pathological, but there's things that we can't represent in Blender. So I was thinking about how are we going to do fabric-based IK from Blender to Bevy, right? And obviously Skein, which we just did a release for earlier in the stream. But the interesting thing here, I think, is that you can't do loops in Blender. Do I not have Blender open? Did I close Blender? I closed Blender. That's what I get for closing applications. Let that be a lesson. Never close an application. Keep everything open. Just use another desktop. If I get rid of this and we do like armature here, right? Like we can't really do a loop for this. This is, if we tab into edit mode, I guess the other thing that's interesting is like when I end up making a video about this, I might use this visualization because the bone itself, when you select the bone, selects both of the joints. For some definition of the right position, I don't know what that's a reference to, Xavier. Need more context. Use a particular desktop number for a particular app. I could. So we have this, I'm playing the animation for some reason. We have this bone now, right? And we can like make more, right? It doesn't really matter where these go. We can make more. The one thing we can't do, notice how all of these are like connected to each other. And if we look at the armature over here, this is like, here's a bunch of bones that are parented to each other. We can't loop this. We can't do a closed loop in Blender. We can't specify that. Like that is not a thing that we can do. It is an iterative solver to get a perfectly correct solution without any no. Oh yeah. Yeah, I mean we're not we're doing game dev IK. We're not doing NASA IK. So when I say that it resolves, I mean it resolves within the tolerance that we've specified. And the tolerance that we've specified relative to like scientific precision is pretty coarse, right? It's like 0.01. But if we were trying to like really do something, like in the real world for like NASA, I imagine we would need something much higher precision than that. Especially if you were dealing with much bigger numbers, right? Where like 0.01 could like mean a boatload. Like cycles. Cycles the renderer or cycles like a cycle of like bones. But yes, like cycles. So the algorithm that we're working with can work with loops. If we go back to the paper for a second, this section is on closed loops. What about cycles the renderer? I don't know what cycles the renderer was a reference to. Sorry, I lost it. It's not in my head anymore. So 4.2 specifies closed loops and shows one. Oh, you meant takes a long time? Yeah, okay. This is a closed loop. This is showing an example of closed loop. So you end up with a triangle with 3 bones that are all closed, right? You want to move P1 to the target. So you move it to the target. Then you move the P3 into the same position like we normally do with fabric. P2 into the position for P3. Then you do, oh, that's not what I wanted to do. Then you do it to P1, then you do it back to P3, and like eventually you get the triangle moved over to the side. This is interesting. This is potentially useful. Is cycles iterative? I think cycles is ray traced, right? So I don't know that I would call cycles iterative, because in my mind, it's not really iterating so much as just firing more, right? Like it's a path traced renderer. So really what you're getting is noise. So if you run longer rays and you run more rays, you end up getting less noise. If you run it for longer time, you get less noise, like that kind of thing. But it's just firing more rays at the end of the day, right? Yeah, so Fabric can handle closed loops. And there are particularly interesting scenarios in which it does handle closed loops. Another thing that it handles is end effectors in the middle of a chain. In your mind, cycles is iterative Monte Carlo or Las Vegas for the US. Yeah, sure. I can get behind that. I guess it depends on whether they actually use Monte Carlo or something else, but I don't know about the implementation enough to say if it's Monte Carlo or a different approach. So you can put the end effector, the quote unquote end effector, right in the middle, which is wild. And the answer for how you do this is you iterate in both directions away from an end effector, which is interesting because that's not the assumptions we've made in our current implementation. Our current implementation assumes that there is some root and some endpoint, and the endpoints are end effectors, and the root is not an end effector. But in this case, we have a position for P4 that wants to go to target, and we have a root P1 that wants to stay in its position. And thus P6, which is not a root, gets pulled to the side. P4 moves to its position, and you get this like curve. The way that I understand this working is you go out from P4 to the edges and then back to P4. So you still do a forward and backward pass, you just do them in a slightly different way. So theoretically, we could modify our algorithm to work in this way, right? We could go from end effector, whatever those are labeled as, and we can go in each direction. That potentially breaks down at some point. So they talk about self-collision and some other things that we're not going to talk about. They talk about joint and model restrictions in the next section. Joint restrictions are something that's talked about in the first paper. This is another example of a closed loop. This is what feels weird. This is figure 9, right? So unfortunately, figure 9 is talked about on like 3 pages earlier, 4 pages earlier, something like that. Here's figure 9. So joint control and closed loop chains. 5 phases for this closed loop chain. And they keep calling things noisy joints, but they aren't particularly specific about what a noisy joint is. Right now in my head, noisy joints are joints that might be either participating in multiple chains or are not end effectors. That is something you find more useful in practice than loops. What is the middle? Like the middle pole? I could see that. So kind of the point that I want to make here is I've just started to get into this, but distances are generally held statically, right? So a distance for a bone is generally, except for prismatic joints, as I throw things across my desk. Prismatic joints can have like a min and a max value, which also works in fabric. But for the most part, for everything else, all the bone lengths are static. Loops would be useful to animate donuts. To animate donuts? Target in the middle of a bone chain might be useful to do the same thing that Blender IK poles does. Yeah, I don't really understand poles yet, though. Useful to animate donuts. Like the food a donut? Or just like donut shapes? I can't get like a chocolate glazed donut out of my head now. In Blender IK, you have to target to specify where the foot hand is and the pole to specify the direction of the elbow knee pointing. Ah, okay, gotcha. I wonder what a pole is. We should look into what poles are. Actually, the other thing that we should do is search the doc for the word pole. Pole is not found here. So it's not in this paper. BlenderArtist.org, somebody asked, doing free advertising to this random site. What a pole target actually is. Pole target, secondary target for a bone with an IK constraint. First target is where the chain of bones is trying to get to. So first target is target. Second target, the pole target, is where the chain bends to get to this target. Chain of bones like upper arm, forearm. I feel like it's like a control point on a curve. I definitely do not mean the Blender Guru donut. I'm good. I don't need to do that. Pull target, pull target. I'll do some research into pull targets. I don't really understand what a pull target is currently, or how it would fit into fabric is really kind of the thing that I'm imagining. Control the direction the chain bends in. Yeah, but controlling the direction the chain bends in is like a joint restriction, but like what kind of joint restriction is it? Is it just like a 180-degree plane joint restriction? Like, not sure. I'll have to look into it. I don't know exactly what it is. And by exactly, I mean, I don't know what the code would look like to implement that specifically. Okay, so anyway, closed loop chains. Closed loop chains in this paper are used for human body motion capture, like IK animation. They classify this as a 5-phase algorithm. That kind of says to me that we need to know this is a loop before we can do it. This is the 5-phase thing that they're talking about. So I think P3 and P4 are labeled here, but are P3 and P4 specified as end effectors, or are they are just the noisy joints? That's what they're referred to as. Attempting to correct the noisy joints. I have no idea what a noisy joint is. Maybe we'll search the paper in a second. So it's like kind of unclear why they choose P1. Right? In a generic sense that we could translate to our code. It's kind of unclear to me why they choose P1 here, which kind of says to me that this needs to be like a user choice of some kind, like to specify the root. Because if you specify the root and you know this is a loop, then you perform the algorithm in one direction of the loop, then you perform the algorithm in the other direction of the loop. In the first, I guess the first phase, you do P1 to P3 twice. So you go P1 to P3, P3 to P4, P4 to P1, P1 to P3. And I don't know if the number of steps there is applicable to any number of bones. But in any case, one of the things that I wanted to mention was we can't set this example up in Blender. The only way we can set this example up in Blender is if we introduce a new component that you can put onto a bone, which you can do with Skein, and we set up, say, the entire, like if we set up the line here at the top, P2, P3, P4, P5, or something like that, and then you specify P3 to P1 and P4 to P1, I feel like this turns into a many-to-many relationship, so we might have to make some sacrifices. But another approach we could do is basically label P1, P3, and P4 as being a loop. Let us give it an ID of some kind. Say this is a loop, this is loop 1 or something like that. So you would have to specify the loop, the root, and then it's unclear to me what D is. D feels like coming in from all of the end effectors, like end effectors to quote unquote noisy joints. So this is like a forward pass. I don't know. It's like, it's weird. You might be able to do this in Blender using a constraint more than the IK constraint to copy the position of a bone base to the tip of another bone. Yes, you would have to use in Blender IK constraints to achieve this in any capacity. I've seen people make exceedingly weird setups to work around the fact that this wouldn't work in Blender. I've seen people do things like they create a full loop, but instead of creating a full loop, they do like a vertical bone at every joint connection and also the loop around at all those joint connections. People just do weird stuff to get around that restriction. So B is first phase, C is second phase. So this is first phase over here. This is second phase. Third phase, where the other true joint positions contribute to correction of interjoint distances. And the last two phases are phase 1 and phase 2. And this feels arbitrary. Maybe I missed something in the paper, but like this way of doing it feels arbitrary. And if it's arbitrary, then we kind of have to like let the user specify how they want it to happen. And this is relevant because specifically, if I go down to this is all joint restriction stuff. Joint restriction stuff should be easy moving forward. Joint restriction stuff is like on a bone. Or on a joint, sorry. We're going to have some kind of enum on that node, or at least from a node, or like on an edge, I think is really what we're going to do. There's going to be a directional edge. That directional edge will have a joint restriction of some kind. And then we can put that on these things. This is what I wanted to look at. There's a couple of examples that are like this, but this has 4 hinges, a pivot, 2 loops, end effectors on hands, feet, and head. And I think the middle is the root. Oh yes, to get around the restrictions that make armatures behave exactly as you want, you'll need a special rig, and a rigger is a full-time job position, one that needs a lot of work training. Yes, rigger is a full-time job position. We are not, we're not becoming riggers today, but figuring out a way to do loops that exports to Bevy would be cool. Specifically because of this. Because when I was thinking about, if we're going to do spiders, right? Or we're going to do turrets, right? Spiders and turrets, IK mobs. Then each of those has somewhere between 4 and 6 legs, we'll say. Maybe between 3 and 6 legs. And I think that one of the options is to basically route all of the separate IK chains at the base of the model, right? If you have um, a spider body or a turret body, and the legs are like 2 bone legs, right? Each of them are 2 bone, 2 to 3 bone legs. And those are like 3 to 6 separate IK chains. That all works. Then we just need joint restrictions and we're done. If we want to get that secondary motion, though, how do you get that secondary motion, right? And if you have a spider or a turret, turrets are like solid, right? IK turret. Let's do inverse kinematics. Mobile turret. Typing is not going well today. This is all like actual game development. Let's take inverse kinematics off of this. So let's say something like this, right? This is a random turret, whatever. Or even this one, right? Where the wheels and the base can shift or whatever. But like this one has 4 legs. It has 2 bone IK for the legs, maybe 3, depending on how the toes work. There's some joint restrictions here to keep things in specific spots. But you either have the choice of doing 4 separate IK joint legs, right? In which case the base has to be controlled a different way. Or how do you set up the rig such that like the legs and the body fit in the right spots? Because your 2 choices are basically like extend the base of the leg into the body to meet another bone, or to have a set of second bones or a loop that represent like the base of the turret. And I think it would be really cool to have that kind of like secondary movement in the turrets. But TBD, I don't know. If you go down to like super simple, like this kind of thing, this is just 1 bone. It's just 1 bone that points at anything, right? So you don't really need IK per se for that. Or you can use open source robot simulation tools instead of Blender. Are there open source robot simulation tools that would allow us to construct the bone armatures for robots that we could use with maybe like Blender modeled 3D models or something? Do you know of any? I don't know of any. I would have to look into them. But yeah, I don't know the answer. I think that the next thing that we want to do is constraints. Yeah, I don't know of any either. The next thing we can do is constraints. And if we do constraints, then the legs will work. And if the legs work, then everything's good. And then we can start sort of like play around with different approaches rather than just guessing. But yeah. You do not think a look is necessary. If you want the body move to match legs target, just having a root bone at the base, it does not deform the mesh, and the bone corresponding to the body in all the IK chains. So multiple targets is enough. Maybe multiple targets is enough. You think one bone at the root with a split for all the legs? So like, where's Blender? I never have anything on the I use so many desktops and I never have the thing that I want on the desktop that I want. Um, X. Nope. X. Bones. So like theoretically, not up, but down. And then this would theoretically have, maybe I can do it from here. Yeah. Extend for like a leg out here, right? This is the most terrible example, but like leg out here, leg out here. Something like this, that would then work out like this. This is just a temporary visualization, so I'm not really worried about this being weird. Yeah, I know he said the loop isn't necessary. Yeah, I know. I'm asking if this is what he's thinking, like from bone perspective. Um, I guess, and then joint restriction. The only thing that gets me here is that there's no. So I split this bone. Like this feels better because there's going to be like some body to the creature or turret or whatever, right? So like, oh, that's not what I wanted. So theoretically, if we had like some theoretical body here, maybe wireframe mode is a good idea. Then this could theoretically go. Am I going to be able to position this? Yeah. So like how this is attached to kind of like that that area. So there's the bone connecting to the base inside of it, and then the bone connecting that doesn't move. Like this is kind of like a root position, if you will. And then the two legs. No, a bone of the origin, a child bone of this one for the body. And then a chain of bone children for each leg. Let's get back into. So you're thinking like this for body. And then wow, my selections are already terrible. Um, right. And then maybe these split. The bone of the origin. So this bone, you're saying, doesn't deform anything, which is fine, right? And then theoretically, this needs to get recentered, but that's fine. Like this still needs to subdivide, right? Because if we're going to put that sphere back, I want this joint to be like the root of the outside of the creature, right? So then we have, right, like this all around. Oop, that's not what I wanted. So this is our, we'll call this like the front of the leg. We'll call this like the part that's reaching out from the actual creature. This is internal at this point. So it's probably just too tall for it to like be reasonable, but I think the thing that I'm thinking about is the base here, right? Right. The oh, that is so weird. Hang on. No, that's right. So we've got transform bone chain for the leg, transform bone chain for the other legs, bone here that goes up. And this is the root of our armature right at the center here. So then I guess if that's the root, right? And the toes are our end effectors and the head is our end effector, then the root is always in the same spot and the restrictions on the joints that are first bones of the root. So these all have joint restrictions that don't let them rotate. Uh, there is no bone that will be the origin, the joint inside of this cluster of bones. So where you see the origin, like world origin right now, the circle, that's where the origin is. And then if that's our transform, right, that's our root transform, then we effectively have 5 children, which lines up with our kind of bone architecture here. This is a parent. This is the child of that parent. I guess we have an end effector at the top. And we can kind of just specify where we want that to be offset relative to the base. But that doesn't really give us the effect that I was kind of looking for, I think. Because if the root's always going to be in a static position, right? It's the root. Then these can all be separate chains, right? There's no reason for this bone to be here. This bone doesn't do anything. This is the same rig as, I unparent this easily. Oh. If these 4 interior bones didn't exist, then this is the same rig. You're doing a quick rig? Sweet. Thank you. Xavier, I think, probably has more Blender experience than I do. Like, I was kind of thinking that I would end up with something that looks like this from all sides, where the triangles for each of the legs would then be like the constraints, so to speak, which I that guess could then be like two triangles to satisfy the whole constraint. But I don't know. It's hard to visualize something that you can't actually author. You don't know rigging a lot. You have a lot of Blender experience, but not recent. Yeah, fair. Um, well, while Xavier's doing that, we'll say the human rig algorithm here uses, I think where's C? C is mentioned here. Subbase C. So figure A shows two hand chains. So from the shoulder out, shoulders are subbases, I guess. No, shoulders are parts of loops with additional chains. The figure B is the loop plus the two chains that go off of it, but not the other loop. So this starts to feel a little bit like it's a manually set up and not something we can auto discover. Right? Because like the ordering here is, if the middle of the body is effectively the root, right? Then we are doing hands to shoulders, upper body loop, lower body loop, legs, head. So just something that I need to spend a little bit more time thinking about. In any case, the next thing we're going to do is joint constraints, I think. And for joint constraints, we'll do something far more simple in terms of rigging. The rig for a joint constraint is just going to be something, let's get out of edit mode. The rig for a joint constraint is going to be something a little bit more like, I don't know, something like this, right? And then this joint can be restricted in all degrees of freedom except for one rotation. So except for rotation on the x-axis, or sorry, z-axis, which is y in Bevy. So we'll let it rotate on the z-axis, but not anywhere else. And then we'll let the forward-facing one rotate in, I don't know, maybe the XZ plane-ish, right? It can look up and down, can go side to side. Maybe that's a Z rotation and a hinge in the Z. Actually, that's not, no, because this would rotate and then that would only need to go up and down. I think that's what I would want to do. So we would say that this probably maybe doesn't move at all. Or maybe this doesn't exist. Maybe this is just like, maybe this is the rig. And the rig is this joint doesn't move position, can only rotate. This joint kind of rotates based off this one, and then can only go up and down. So this has to rotate z-axis to like move a turret, and this will point at wherever it's trying to point at. And then we'll have a couple of fairly easy joint restrictions. I don't think I'm going to do that today, but I think that's the next thing we're going to do. That at least makes it like um, pretty easy to think about in terms of, is the joint restriction doing what it's supposed to, right? Like, if we had something like this, and then we had like UV sphere, which has way too many vertices for what it's about to be, but you know, is what it is. And then the scale a cube down, bring it up to the right position. This is supposed to be y-axis. So we do something like this, move it, don't scale it, move it. I like to move it, move it. And then this is like a really janky rig for like a theoretical turret. And we can actually model something and make it look nice and stuff. But this is enough for like working on the joints itself. Joint rotation restriction constraints is definitely the highest priority for IK use, maybe not for learning teaching. I think joint restrictions are the next thing. Joint restrictions are, I wanted to get multi-end effector working. I hope that multi-end effector is useful, but I don't know that it will be. Multi-end effector was cool to do, and that does set us up well for doing joint restrictions in general, because now we have a graph. We can just say like, there's a joint restriction from this joint to that joint or whatever, which is cool. But yeah, the restrictions are definitely the next step for the IK stuff. I think the multi-end effector model constraints is what I'll call them. The closed loops. I don't know that we'll get to that. I don't know that that's, if we can figure that out, that would be very cool, I think. But it still might not turn out to be like the right effect. So TBD. In the meantime, everything's working. So maybe I'll write a couple more demos for this as well. I don't know how far I'm going to push this project past this point. A bit off topic, but are you using BlendV? No, Skein is my thing. BlendV hasn't been updated since 0.14, I want to say. But I really liked what it did. So I started looking into it, I don't know, earlier this year. And Skein is what came out of that work. So if you're looking for components on Blender entities that comes into Bevy, Skein is current state of the art. I'm not aware of any other library that does this currently. BlendV is, I guess, effectively dead right now. You got to know about it from my channel only? Well, I made it, so. Oh, you mean BlendV. You don't mean Skein. Yeah, so BlendV has been 9 months ago was the last merged commit, which is quite a while. A couple of people have done attempts to like upgrade it. So like 15, 16, but you can see that like 17 fell off and doesn't exist anymore. I think they just had life stuff show up, which is, you know, fine. You sent the blend file on Discord General. Sweet. Let me see if I can. Just pop it open. Yeah, you didn't fix the bone roll. That's fine. We don't have yeah, so I'm wondering how you are intending to do these gaps, I guess. I don't have a great way to show this at the moment. I don't really want to pull up Discord on my stream computer. But yeah, there's gaps in that rig, right? And the IK stuff is all of the bones are fixed distance from each other. Unless you mean that the gaps are supposed to be like bones that are static, I guess. Which is the same thing as I had before, I think. But I think that's it for stream for today, I think. I've got a bunch of stuff that I want to write. I want to get some of these workshops done for Rust Adventure. I need to do Rust Adventure website work and stuff. But things are looking pretty good overall. Skein is out. If anybody is using Skein and wants to update, 0.4 is out with 0.1.13 for the Blender integration, which is cool. And that's going to be it for me for today. Probably stream again tomorrow. Have a great rest of your day, y'all.